What's up guys, this is Massey. Welcome to another video. In this video I want to talk about binomial expansion when the index or the exponent is a rational number or it's a negative number. So as you remember, we had earlier that for any positive integer n or index of the binomial expression, and for any real number of x, we can say 1 plus x to the power of n is going to be nc0, which is going to be 1 plus ncr times x plus nc2 x squared and so on to get to ncn x to the power of n. So we can also write it like this: 1 plus x to the power of n equals to 1 plus sigma r equals to 1 to infinity n times n minus 1 times n minus 2 all the way to n minus r plus 1 over 1 times 2 times 3 all the way to r times x to the power of r. Let x be a real number between negative 1 and 1 for any real number m, as you see here. We can write it as 1 plus sigma r equals to 1 to the power of infinity m times, that's exactly what you see in here. So we can, if x is between negative 1 to 1, we can extend it to any real value for m. So next, let n be the positive integer and x between negative 1 and 1. 1 plus x to the power of negative n, so it's going to be a negative number. That's going to be sigma r0 to r infinity times negative 1 to the power of 0 n plus r minus 1 cr times x to the power of r, or it's gonna be 1 minus x to the power of n. When you have negative instead of positive, you're gonna have sigma r equals to 0 to infinity n plus 1 minus 1 cr times x to the power of r. And when you have the rational numbers, you can write all these expressions when we have 1 plus x to the power of m over n, or 1 minus x to the power of m over n, 1 plus x to the power of negative m over n, and 1 minus negative m over n. So you can write any kind of expression like that. So let's see some examples. So the first one, it says obtain the fifth term of 1 plus x over 3 to the power of negative 8. So if you compare it with the equation we had here, that's going to be very similar. 1 plus x to the power of negative n equals to sigma r equals to 0 to infinity negative 1 to the power of r n plus 1 r minus 1 cr times x to the power of r. So here we can do the same thing. Negative n, I'm gonna make it here, negative n is gonna be negative 8, so I'm gonna say n is 8, and r plus 1 is 5 because it's fifth term, so r is gonna be 4. So t5 equals to t4 plus 1, and when you sub it there, it's gonna be negative 1 to the power of 4 n, which is 8 plus 4 minus 1 c4 x to the power of, in this case, x over 3 to the power of r, which is 4. That's gonna be negative 1 to the power of 4 is gonna be 1, so forget about it. 8 plus 4 is gonna be 12, minus 1 is gonna be 11, 4 x over 3 to the power of 4. So that's gonna be 11 factorial over 4 factorial, 11 minus 4 factorial, x over 3 to the power of 4. That's going to be 11 times 10 times 9 times 8 times 7 factorial over 4 factorial times 7 factorial, x over 3 to the power of 4. So 7 factorial and 7 factorial cancel out. 11 times 10 times 9 times 8 divided by 1 times 2 times 3 times 4. So that's going to be 110 divided by And here we have 3 to the power of 4. With that one is going to be 27 x to the power of 4. So that's going to be the fifth term. Now let's look at the next example. Next example, it says find the sixth term in the expansion of 1 minus x squared over 4 to the power of negative 4. So in this case, again, that's minus in between, so we need to follow this one. So n is 4, r plus 1 is 6, so r is 5. So T6, which is gonna be n plus r minus 1. So 4 plus 5, 9 minus 1, 8. CR, which is 5 times x squared over 4 to the power of 5. So that's gonna be 8 factorial over 5 factorial over 3 factorial x squared over 4 to the power of 5. So that's gonna be 8 times 7 times 6 times 5 factorial over 3 factorial 5 factorial. These two cancel out. X squared over 4 to the power of 5 will be, that's gonna cancel out with 4. It's gonna be 7 over gonna be 7 over 4 to the power of 5, x to the power of 5 to the power of 2, or 2 to the power of 5 is going to be x to the power of 10. Let's see the next example. Determine the fifth term in the expansion of 6 plus 5y over 11 to the power of 6 over 5. So, I'm going to write 6 plus 5y over 11 to the power of 6 over 5. You factor 6 out. 1 plus 5y over 66 to the power of 6 over 5. So fifth term is going to be 4 plus 1. It means that r is 4. It's going to be 6 to the power of 6 over 5 times based on this formula, which is the first one, is gonna be 6 times 6 minus 5, 6 minus 2, 5, 2 times 5, 6 minus 3 times 5 over 1 times 2 times 3 times 4, 5y over 66 to the power of 4. Which is going to be 6 to the power of 6 over 5 times 6 times 1 times 6 minus 10, negative 4, 6 minus 15, negative 9, over 1, 2, 3, 4, 5 over 66 to the power of 4, y to the power of 4. So that's going to be the fifth term in the expansion of 6 plus y, 5y over 11 to the power of 6 over 5. Let's take a look to the next one. Find the 10th term in the expansion of 3 minus 4x to the power of 2 over 3. So when we say 10th term, it means that r is 9. 3 minus 4x to the power of 2 over 3 is going to be 3 to the power of 2 over 3. 1 minus 4x over 3 to the power of 2 over 3. So that's going to be T10 equals to, the formula we can use here is gonna be this one in here, r1 minus x to the power of m over n, and we need to consider this part, which is gonna be negative 1 to the power of r, which is 9 m times m is 2, and n is 3, m times, so 2 times 2 minus 3 times 2 minus 2 multiplied by 3, 2 minus 3 times 3, all the way to 2 minus 8 times 3. Divided by 1 times 2 times 3 times all the way to 9, because r is 9 times 4x over 3 to the power of 9, 3 to the power of 2 over 3. The reason I wrote 3 to the power of 2 over 3 is because we took it out. So now we can simplify it. It's gonna be, that's negative 2 times negative 1 times 2 minus 9 is going to be negative 7, all the way to 2 minus 24, which is going to be negative 22, divided by 1 times 2 times 3 all the way to 9, 4 over 3 to the power of 9, 3 to the power of 2 over 3, and x, you take it out, x to the power of 9. So that's going to be the 10th term in this expansion, which is 3 minus 4x to the power of 2 over 3. Next one, what are the values of x for which the binomial expansion of 3 minus 4x to the power of negative 7 is valid? What does that mean it's valid? It means that when the x is between negative 1 and 1. So here we have 3 minus 4x to the power of negative 7. So we can take 3 out. It's going to be 1 minus 4x over 3 to the power of negative. So 4x over 3 has to be between negative 1 and positive 1. It means that 4x between negative 3 and positive 3. It means that x between negative 3 over 4, 3 over 4. Or we can say absolute function of x is less than 3 over 4. Next one, find the coefficient of x to the power 4 in 1 minus 4x to the power of negative 3 over 5. So we can say 1 minus 4x to the power of negative 3 over 5. We can say tr plus 1 equals to, for this format, it's going to be m times m plus n times all the way to m plus r minus 1n over 1, 2 all the way to r, x over n to the power of r. In this case, m is 3 and n is 5. So we can say t of r plus 1 is going to be 3 times 3 plus 5, 3 plus 2 times 5, all the way to 3 plus r minus 1 to the times 5 over 1 times 2 times 3 all the way to r, 4x over 5 to the power of r. So here it says find the coefficient of x to the power 4. When it says x to the power 4, it means that r is supposed to be 4. So t5 equals to 3 times 3 plus 5, 3 plus 2 times 5, 3 plus 3 times 5, over 1 times 2 times 3 times 4, 4x over 5 to the power of 4. So that's going to be t5 equals to 3 times 8 times 13 times 18 over 1 times 2 times 3 times 4, 4x over 5 to the power of 4. So that's going to be 4 to the power of 4, x to the power of 4, 5 to the power of 4. So the expansion is going to be, when you do it, it's going to be 13 times 18 times 256 over 625. So that's going to be the coefficient of x to the power of 4. Next example, using the binomial theorem for rational index, find the appropriate value of 242 to the power of 1 over 5, correct to 4 decimals. So 242 is 1 less than 243, and you know 243 is 3 to the power of 5. So 242 to the power of 1 over 5 equals to 243 minus 1 to the power of 1 over 5. So we can take 243 out. Two 43 to the power of 1 over 5 is going to be 3. 1 minus 1 over 243 to the power of 1 over 5 is going to be 1 minus, based on the formula, 1 over 5 times 1 over 243 plus 1 over 5 times 1 over 5 minus 1 over 1 times 2 multiplied by 1 over 243 to the power of 2, and so on. And here 243 is 3 to the power of 5, so that's going to be 3 to the power of 5. So we can say that's going to be 3 minus 3 over 5 0.00243 minus 3 over 2 times 6 over 25 0.00243, and all the way to these terms is going to be, some of them are going to be neglected, whatever is after 4 decimals. So when you do that, it's going to be 2.998541, which you can say is approximately 2.9985, because we are looking for only 4 decimals. Now let's look at the last example. This one, it says find the approximate value of square root of 4 plus 3x over 3 minus 2x to the power of 2 when absolute function of x is so small we can neglect x squared and higher power of x can be neglected. So I can say square root of 4 plus 3x over 3 minus 2x to the power of 2, that I can factor root 4, 1 plus 3x over 4 to the power of half. This one is going to be 9, 1 minus 2x over 3 to the power of 2, that's 2, over 9, 1 plus 3x over 4 to the power of 1 half, 1 minus 3x over 2x over 3 to the power of 2, which is going to be negative 2 when you bring it in numerator. So it's going to be 2 over 9, 1 plus 3x over 4 to the power of 1 half, 1 minus 2x over 3 to the power of negative 2. So when you expand it, you need to neglect x squared and higher powers. So this one, when you expand it, is going to be 1 plus 1 over 2, 3x over 4. And here, that one is going to be 1 plus negative 2 times negative 2x over 3. When you multiply it, it's going to be 2 over 9, 1 plus 3x over 8 times 1 plus 4x over 3. Which makes it that 2 over 9. When you multiply it, again these two, when you multiply that, you need to neglect it. So it's going to be 1 plus 3, 8 plus 4 over 3x. It's going to be 2 over 9, 1 plus 41, 24x when you do common denominator, which will be 2 over 9 plus, then you multiply that, it's going to be 41x over 108. That's going to be the final answer. I hope you enjoyed this video. Please leave me a comment if you have any question. Please don't forget to subscribe to this channel. You can find out lots of videos regarding binomial expansion and other topics in math, physics, and chemistry. Thank you for watching and have a great day.